Hello dear student, myself Vikash Kumar. Today I am going to teach calculation of equilibrium constant. So this question is previous year question of IIT. Now I am going to solve this question. Watch my video carefully. Now first we read this question carefully. The molar concentration of X, Y, Z are 2, 2 and 4 mole per liter respectively in the reaction X plus 3Y, symbol of reversible reaction, 2Z, 2 mole of Z product is formed. Find out the reaction equilibrium constant. So first I can write this reaction. Answer is X plus 3Y in reversible reaction 2 mole of Z is formed. Now for calculation of K, now given data in mole per liter, so this is the unit of concentration, so Kc. Now we can find here equilibrium constant for concentration. Concentration of, formula is concentration of product divided by concentration of reactant. Now from reaction concentration of Z, and we can write here 2 stoichiometric coefficient concentration of X into concentration of Y, here stoichiometric coefficient 3. Now from question, X, Y and Z are respectively 2 to 4. So X is 2, Y is 2 and Z is 4 mole per liter, mole per liter and mole per liter. So these datas we can put this formula. Z square means 4 square and X means 2 multiplied by Y cube. Y cube means Y means 2, 2 to the power 3. So after calculation we can observe here 16 in by 16. So 1 is answer. Now these 4 options are given, so option A is correct. You can take a screenshot. Now we will discuss about next question. Now I am going to solve next question. This question is based on calculation of equilibrium constant, so watch my video carefully. This question is also previous year question. Now according to question, for the reaction H2 plus I2 to HI, this reaction is reversible reaction. Concentration of equilibrium of H2, I2 and HI are given in mole per liter 8, 3 and 28 mole per liter respectively. Equilibrium constant of reaction, these options are given. So according to question, H2 gas react with I2 gas, then in reversible reaction 2 mole of hydrogen iodide gas is formed. Now given that concentration of H2 is 8 mole per liter, concentration of I2 is 3 mole per liter, concentration of HI is 28 mole per liter. Now according to given data, all data are given in mole per liter in terms of concentration. So equilibrium constant for concentration we can find. The formula is concentration of product divided by concentration of reactant. Now in this chemical equation, concentration of hydrogen iodide in mole per liter, stoichiometric coefficient we can write here in terms of power divided by concentration of H2 and concentration of I2. So we can put here all data. So value of concentration of hydrogen iodide 28, so 28 square and divided by H2 8 mole per liter 8 and I2 3, so 3 mole per liter. We can write after calculation 28 into 28 divided by 24. So after calculation you can check 32.66 is answer. So option D is correct. You can take a screenshot. Now I am going to solve this question. This question is also based on calculation of rate constant. According to this question, in a chemical equilibrium, the rate constant for forward reaction is 7.5 into 10 to the power minus 4. Given that value of the rate constant of forward reaction is 7.5 into 10 to the power minus 4, and equilibrium constant K, equilibrium constant is 1.5. Rate constant of backward reaction is, options are given. So rate constant of backward reaction is, sign of interrogation. Now constant of equilibrium is equal to constant of forward reaction by constant of backward reaction. Now we can solve this question. Value of equilibrium constant is 1.5 and forward reaction, constant of forward reaction 1.5 into 10 to the power minus 4. Now divided by kV. Again, therefore value of kV is equal to 7.5 into 10 to the power minus 4 multiplied by 1.5, 5 into 10 to the power minus 4. This is the answer. Now you can check in these four options. Option D, 5 into 10 to the power minus 4, 5 into 10 to the power minus 4. Now this question is solved right now. So this is correct answer. You can take a screenshot. Now this question is completely based on calculation of equilibrium constant for concentration. Here value of Kc is given. Then with the help of Kc, how we can write a balanced equation. Now according to this question, expression for equilibrium constant is given. Kc is equal to this part. According to this expression, write down the balanced equation. So this question is completely based on formula for the calculation of Kc. Case 1 for reversible reaction. For reversible reactions, A plus B, C plus T. We can write here value of Kc, concentration of products divided by concentration of reactants. Now according to this equation, concentration of C into concentration of D divided by concentration of A into concentration of B. Okay, this is the case number 1. Now in case 2, we can write here, you can take a screenshot. Now for case 2, we can write here, in the case of reversible reaction, with the use of stoichiometric coefficient in reversible reaction, value of Kc, equilibrium constant, concentration of products by concentration of reactants. Right here, concentration of product. Here a stoichiometric coefficient used in terms of power of concentration. So value of Kc we can write in this way according to given reaction or reversible reaction. Now according to this question, we can find Kc. So with the help of value of these terms, we can write equation, or with the help of equation we can find Kc. So according to question, Kc value is given. Now we can solve with the help of this formula according to question. Okay, we can write here Kc is, now Kc is in question, Kc is NH3 in terms of concentration power 4, O2 power 5, NO in terms of concentration power 4, H2O here 6. Now the formula is concentration of products by concentration of reactants. Okay, you can take a screenshot. Now we can write here formula reactants to products. Okay, so 4NO gas plus 6H2O. Now we can use here symbol of reversibility because reactions, this is applicable for reversible reaction. Now with the help of this formula we can write here a balanced chemical equation. Reactant 4 mole of NO gas react with 6 mole of H2O gas. Then after reversible reaction 4 mole of NH3 gas plus 5 mole of O2 gas. So this is final answer. Now we can balance 4 nitrogen LHS, 4 nitrogen RHS, 4 oxygen plus 6 oxygen, 10 oxygen in LHS, 5 to the 10 oxygen in RHS. Now in case of hydrogen, 6 to the 12 hydrogen and 4 3 is 12 hydrogen. So this is correct answer. You can take a screenshot. Question is solved right now. Now I am going to solve question number 5. This question is based on calculation of equilibrium constant. So watch my video carefully. According to this question, for the reaction H2 plus I2, 2 HI, 2 mole of HI is formed. Concentration in equilibrium of H2, I2 and HI are respectively 9.6, 2.6 and 3.8 mole per liter respectively. Calculate equilibrium constant. So according to this question, given that H2 gas react with I2 gas form 2 mole of hydrogen iodide gas. So here concentration of H2, concentration of I2 and concentration of hydrogen iodide is given in mole per liter. So in case of 1 mole of H2, concentration 9.6 mole per liter, I2 2.6 mole per liter, and HI for 1 mole HI 30.8 mole per liter. So according to given data we can find equilibrium constant for a concentration of equilibrium constant. Now concentration of products divided by concentration of reactants. So we can write concentration of H2 into concentration of I2. Now 30.8 square 9.6 into 2.6 is equal to, after calculation we get 38 is answer. So you can take a screenshot